All right. Hello, everyone. My name is Vanity Sky. For those of you that do not know, I am the community manager here at Formation, and I am very proud and excited to bring this event to you. This is our Tables Turn interview, the first one of the year. So a really awesome and unique chance to see our fellows interview our mentors on a certain prompt. So I will not take the floor up today. This is all about our mentor and our fellow today. As a reminder, as all formation sessions go, if you could have your mic off and camera on, that would be amazing. Today's session is going to be conducted by Hemant Heer, and he will be interviewing one of our awesome mentors, Justin Voskuhl. And so it'll be conducted like a normal 45-minute interview, 45 with 15 minutes for live feedback and Q&A at the end. So please, if you have questions during this time, put them in the chat, and there will be a time at the end. We may not get to all of them, but we will definitely try to address most of them. So now I will pass it to you, Hemant, and the floor is yours.
Awesome, man. Thanks, Vanity. Thank you for joining, Justin. Appreciate your time. So let's get started. So today, I would like for you to design the Uber taxi hailing system.
Great. Okay, yeah.
100%. Uber
Well, let's just
question అడిగాడు వీడు రెడిట్ లో ఆర్కిటెక్ట్.
Oh, but I think we have some.
Can you please mute? Everyone, please mute yourselves for the duration of this event. Thank you.
Thanks, Al. Okay, yeah, let's get into asking some just some questions around the sort of stuff that we're going to design, like what's on the table, what's not, because obviously Uber is a really big system. So why don't we just, if it's okay with you, talk about maybe the primary experience of the rider, but maybe also a little bit about what the driver's experience looks like. Those are our two clients, and then we can talk about maybe their client server actions with the data center, and then what the data center application looks like. Maybe if that seems okay to you. So maybe I could just draw up some requirements, if that's okay. Just sort of like just talk about what we're going to discuss, and then maybe you can give me some feedback on my bullet points. See if I'm sort of hitting the mark. All right, so let's see. Let's start with one that riders can open the app and see where they are, and if service is available. I'm sure a lot of people have had the experience, you open up the Uber app in some faraway city, it's like, oh, I'm sorry, we don't actually have Uber there. So there's that one experience where like maybe it's not available. So this is where you can go and you can see if it's available. And then maybe a little sub bullet. If it is available, you see ghost cars driving around the map. This kind of is that like you get a sense for like, are there a lot of drivers available? I actually I've never worked at Uber, so I don't have any inside knowledge of whether those cars are real that you see on the map. But I think the idea is it gives you some sense that like there are drivers available. Riders can start a ride and specify a type of vehicle they need. Because sometimes, you know, obviously like, oh, I'm going with a bunch of kids, I need a minivan, or, you know, there's all these options that you could select for the type of vehicle. Riders can see a cost estimate. So you get, you know, how Uber will say, oh, we think this is going to cost about $40, assuming no changes. And I think they even are committed to that as long as you don't change the ride for their vehicle type and destination route. All right. And then riders can see progress on the map as their driver makes their way along the route to the destination. When the driver indicates the ride is complete, the rider will see a summary of, I think you get like a summary of, it's just a basic summary, but it's like distance and time, distance, time, and the cost, like just a final, like, hey, this is what it was. And, this is, we're billing you. And I think it might even, I think these days it prompts you to tip, maybe, is that right? So prompt for a tip. I'm not sure if that's really true on Uber these days. I think it is. I think you get asked like, hey, you should tip your driver.
Yeah.
All right. And then let's talk a little, is that roughly what you had in mind?
Yeah.
There's obviously a bunch of things behind here in terms of payments and identity that we're not really diving into. And then, that's fair to say. I mean, obviously there's a lot in the Uber app that's sort of like hidden behind the simplicity of the screen. And then let's say driver can start a session indicating they are open to accepting fares. Driver will see a heat map of demand. I have not used the driver version of the app, but I have seen a little bit of it. So if people maybe know more about it, I actually have never used the driver app, so I'm making up some stuff here. So just correct me if I'm wrong. I haven't used it myself. But my understanding is the driver, once you say, hey, I'd like to start a session, you see the kind of a heat map of demand, which basically tells you, if you'd like to be able to pick up someone quickly, go to one of the hot areas on the heat map. All right. Driver will be presented with a potential ride. Now, I don't know how much they're told about the rider at this point. I think it may just give them some information about like this person is starting here and would like to go here. You don't really learn much else about the person, and I think that's by design. And then if the driver accepts, they are shown a route to drive to the pickup spot. The pickup spot, we didn't really talk about it above, but the rider, when they say I'd like a ride, they actually get a pickup spot, which may or may not be where they are. For example, like if I'm in my hotel room, I'm like, I need a ride. I might say, oh, the lobby entrance is where I want to get picked up. And they actually, I think they can be different. But obviously the app wants to make sure it's not like a mile away, because that wouldn't really make sense. All right. Once the driver is at the pickup spot, they tell the app they have arrived, and a timer starts for the rider to show up. Once the rider is on board, the app shows a route to the destination. The rider navigates to the destination, then once there, indicates they're done with the trip. Is this roughly what you had in mind? It's basically the like request a ride, take a ride, and then on the is that okay? Okay, great.
Yeah, I think for the scope of this conversation, I think these are good points to sort of look at in terms of location, drive, the request ride model. Yeah, I would say that's good.
Yeah, I think there's something good to call out here, which is just like there's a bunch of stuff in the app that we are not discussing, and we're kind of being explicit about this in this kind. That's why that's the kind of the point I think of these bullet points is like, for example, an identity platform, a payment infrastructure, like those all certainly are there, but we're not going to go into them. So now maybe let's talk a little bit about what is in the what's in the data model for Uber. And maybe this is radically simplified, so maybe somebody who works there can tell me that I've simplified it beyond all recognition. All right, so one object we're going to have in the system is we're going to have a person. So person. It is possible in Uber for you to use an identity, and you can be a driver or a rider. Like I can be a rider one day and a driver the next, and they're both people, but they're different types. And I think by default, it assumes, I think, that you're a rider, but you can upgrade yourself to be a driver. So there's going to be a basic information in here, probably a user ID. We're going to have things in here like, your display name. Probably some other things. You're probably going to have, if you're a driver, we have information about your cars. So I'm imagining it is probably actually possible for you to have multiple cars signed up with Uber. You could imagine in your household, you have 2 cars, maybe your spouse needs a car one day, you're going to take the other one. So you can have multiple cars. So here, let's just say you have a car, and the people own cars. So here's a car. There'll probably be data about the car. Maybe every car will get its own ID, but similarly, it'll probably have owner ID, which is like, who's the person that owns this car. You'll notice this arrangement doesn't allow us to like share cars or other things like that, but let's just agree maybe that's okay for this purpose. So a person has multiple cars. There's also probably some records for payments. So like what kind of payments has the person received, either paid or been paid. So some sort of financial transactions, but maybe we'll say that that's part of the payment infrastructure. We're not really gonna talk about that. All right, so if you're a driver, I imagine that we are going to talk about the existence of this concept of a work session. So you're going to start work at a particular time, and you're going to swipe, and you're going to indicate that you end at some other time. So if you're a driver, we're going to call this a session, and this basically just lets us know what rides were accumulated during that session. Maybe if there are special things about that session, like, oh, during the session we had some sort of performance bonus, it applies to the session, so we can kind of look through and make sure that those are applied. And then we're going to have a session ID, and then we're going to have the driver ID. So this is the ID of the driver that's actually driving around this session, driver ID. And we may want to record here other things like what incentives are in place or whatever, but we haven't really talked about, these sort of things. Now, once a session starts, you're going to be able to accept a ride. And so a ride is where the user and driver start to intersect. So here we're going to have something like, we'll call this a ride. This is like an individual, instance of a ride. And it also is going to be a little bit of a state machine. So like it'll move from state to state as interesting things are happening in the app. This is probably where a lot of the rubber is going to hit the road in terms of the actual Uber app, because like manipulating rides is kind of the name of the game. Everything else is to just facilitate and set one up. All right, so let's see. Rides in terms of, they're obviously initiated by a driver in a session. So they have some sort of session ID. So like they're part of this driver's like work stream. So they're there. They also have a passenger. So this is the person who is the passenger. I'm not going to model in the data model the other people that are in the car. So for example, if I call an Uber and there are 3 people that are coming along as my passenger, they're not really modeled in Uber at all. They're just sort of like, I need a car that holds X people, but Uber doesn't really know who they are, and I'm not going to include them in our data model here. Although there are some features that like might kind of indicate, like I think there's a split the fare with my friends feature. We're not going to get into that kind of thing where like maybe we would need to know who they are so that Uber can like charge us all, if it's a $50 fare, it can charge, you and me $25. But we're going to just ignore that. And I can find the driver that goes with this by going to the session and looking at the driver ID on the session. We probably need a state. So there's some sort of state with it, like am I pending pickup? Is it completed? Are we currently waiting for the passenger to arrive? So there's going to be a state machine that progresses through the evolution of a ride. Rides proceed in a bunch of different ways. Obviously, rides can terminate normally, and normally I mean you made it to the destination, everyone's happy with the billing. They can also end very abnormally, like you get into a car accident, or maybe all the phones stop responding, like you don't hear back from the passenger's phone or the driver's phone, like what's going on? We actually don't know. It's in a mystery state. So the state is pretty interesting, and the state machine is probably quite complex with lots of edge cases to think about. So maybe we can dive into the state machine, but I imagine it's quite complex. There's also going to be a pickup location and a drop-off location. These are probably quite complex records in of themselves. I've noticed that Uber not only seems to understand now locations, but if you're in a major building, they have metadata about locations to indicate, like, I know you're in a hotel and I know there's 2 lobbies, and they'll put these points on the map that indicate like these are the preferred locations. So locations can be things like street addresses. They can also be lat longs. You can actually go on the map and I want to be taken to this park. Okay, well, I mean, it's not a it doesn't have a street address, but the Uber will take you there. So they can be lat longs, and they can also be kind of like objects on this data model where like there's a building and I want to be put off on the western lobby. So I won't go into details about the location, but they are pretty rich. They're not just a lat long concept. But I would say pickup locations can almost always be turned into one. So I can take a street address and using a geo resolution, turn it into a lat long, or they can be just lat longs on their own. Or my data of like buildings and their locations will tell me the lat longs of different entrances and things like that. So locations are pretty interesting. And here they're kind of in the record. They might be their own first class concepts. And I'm also not modeling here a multi-point ride. So Uber does permit this sort of thing where you can say, hey, you know, I need to drop off my friend first and then go to my own home. We're not modeling that here. This is just a pick up and drop off. So we've kind of greatly simplified that. I don't know if this has enough complexity in it for what you're aiming for.
No, I would say, yeah, I think the core, I think that is one of the core experiences that definitely I think we should be talking about. I think the other ones are a little bit more complex.
There's almost certainly also something here around the pricing there's a lot of elements to pricing that go into a ride. So for example, you're initially given a quote, and I think it is typically based on time and distance. But there are situations that can change that. So for example, you're in the car and I want to change the drop-off location. That will actually update the pricing to reflect the new price that has to be accepted. So pricing isn't kind of the static thing. It can change. But here we're just going to model it as like, there's a price. You go to the destination and that's what you're going to get billed. In the interest of time, let's move a little bit to the client server architecture here, if that's okay.
Yeah, that looks good to me. Let's go.
All right. So since we have a little bit of the data model, I'm going to draw the clients first. I love to draw these diagrams where you start with the client and build backwards. And so I'm going to start here with a phone. I'm going to make the world's worst looking phone. Let's just make it maybe gray. Okay, and then we'll put in we'll put the screen on there. All right, there's like kind of an old school phone. Okay, there's my phone. And I'm gonna make two of them because there's the driver phone. There's the driver's phone and the passenger's phone. I don't actually know within Uber if these are two separate apps or if you're a driver, just like kind of a new tab lights up within the existing app. I'm not actually sure which it is, but we're going to call this the rider. All right. And so both of these apps are busy talking to this fairly complex data center application. So we're going to fill that in. I don't know. We'll say load balancers are red. They're making it up as we go. All right, so then we have the driver is going to be sending requests to our load balancer. The rider application is going to be doing the same. And we'll call this LB. Now, when you're designing these client server systems, there is kind of this interesting thing about what should the RPC mechanism look like. It's very trendy sort of to have REST APIs, but honestly, a REST API makes a lot of sense if you're not in full control of the client and the server. So I think for our application here, you want to kind of consider like, do we want to have an open API? Like, do we expect third parties to build stuff on this, or is it completely in-house and it's completely under our control? If it's under our control, I tend to think something like gRPC is generally a good choice. So we could even do like gRPC over HTTP. It just gives you kind of a nice, more standardized model where you have this like machine readable definition of your service. And I think in this case, I don't know of any third-party Uber clients. I don't know if they exist or not. I suspect they don't. And so in this case, maybe this will just be gRPC over HTTP or something where we can have a nice machine readable definition of what our interface looks like. Now, maybe let's think about what these different methods are. We kind of have this like list of requirements, but we haven't really quite distilled it down to a list of like what would the RPC interfaces look like. So maybe for the driver, or sorry, for the rider, we need to do some simple things like check availability, and maybe that's kind of a location. And so we're going to send this location up to the server, and we're going to check to see, like, is Uber available in this area? Then we're also going to say, request ride, and we're going to say maybe start location and the, I'm going to call the pickup location. Naming is so important in these things, and you don't want to have multiple names for the same thing. So we're going to call the start location the pickup location, which I think is a little more helpful, because it's not necessarily the start location, right? Like, you're in a building, but you actually want to get picked up down the block for potentially pretty good reasons. Pickup location, and then we're going to say the drop off location. And once you've requested the ride, you're going to get this. List of. You're going to get matched with somebody, and so once that occurs, there has to be some mechanism for you to check to see if I have been matched. That can be through one of two mechanisms. We can have a server client notification bus where we can notify about things in the app, or you can have a thing where the app just periodically every 10 seconds is like, hey, has my ride request been accepted? So, we can do something like check for match. We're going to do the mechanism where the clients just periodically say, hey, did I match yet? And the check for match can also give updated information like, we know we told you we thought we would match you in 90 seconds, but actually, just based on current conditions, we think your match is actually going to come in 2 minutes. So check for match allows us to have a little bit of sort of updated. So we're going to have this request ID. This check for match also can kind of error out. I don't know if you guys have ever seen this, but if you're like at a very busy event, sometimes you do request a ride in Uber and it's like, we're matching you. And it's like, I'm so sorry. There's just like no drive, like we're just out of capacity. So check for match can like fail out in interesting ways. And then I think from here, the passenger doesn't really do a whole lot of interacting with the app. Honestly, everything from here is kind of like the driver is involved at this point. So let's just talk a little bit about the driver. So the first thing is when the Uber driver starts the app, they say, I'm starting a session. I'm getting in my car. I'm all gassed up. I'm ready to work. So here, there's going to be kind of a start session API where the driver is just going to log in and say, I'm ready to start a session. They're going to be given a session ID. The session begins. And now periodically the driver's app is going to go and say, it's the other side of check for match. And it's check for matches. And it's basically going to be saying, like, given everything you know about my session and where I am right now, maybe it's going to give it its current location. Basically going to say, like, what matches are available, if any, and it's going to respond with some different options. It's going to go say here, and we can accept a ride with one of my matches. We're going to basically start the session. And then we're going to have start ride once I get to the pickup location. So we're going to say I'm going to start the ride. And then we're going to do all this driving, and we're basically going to do this like end ride where the ride will come to a close, and basically saying, like, I'm all done with the billing. This is wildly simplified, so I'm not sure this is going to actually meet all of our needs. We're like designing kind of the world's most like basic dumbed down Uber, but let's see if we can work with this initially. All right. So let's see here. I know Uber is extremely famous for having decomposed their service into lots and lots of small microservices. But at least when we hit the load balancer, I'm going to go to some kind of like intelligent traffic router that can inspect a whole bunch of these different things. And let's say that we just have kind of one I don't want to say it's a monolith service, but we have one service here, and we have a bunch of them running. So there are lots of these services. So we're going to just call this the Uber service for now. And we have a lot of them running. So they're going to be running in some kind of infrastructure like Kubernetes. So like we're having the demand for these things. The amount of capacity is in an autoscaler group that is just, I don't know why these are red. Maybe these shouldn't be red. Those will be just gray. And we're going to put these in an autoscaler group. And so the purpose of that is that I want these machines to scale up and down as the amount of demand for our service goes up and down. I imagine that like on a 24-hour cycle, Uber's demand kind of looks like this. So this will help us just make sure we have enough capacity when demand is high to service the phone, not to say we have enough drivers. And then I imagine on weekends, the demand is quite a lot higher. So this will also help us tolerate that. So our load balancer is just going to spray requests across these individual pods. And we're going to assume the architecture here is these machines are completely symmetrical. You can send any request to any machine at any time, and it's totally fine. So they don't have any actual like state floating around inside of them. Now let's see. So let's talk about that first API, this check availability. I'm going to venture here that the locations where Uber is available is not changing all that often. So to that end, we can probably have some kind of global configuration that defines polygons by lat long. So just like it's a polygon of lat long. And we say that like within this bounds, the Uber service is available. Outside of those bounds, it is not. And basically we'll have teams that are like working in different cities to bring the Uber service up. We'll have them be able to configure that. So you could imagine like you're launching it in a new city. Maybe initially it's the downtown core and they can edit it as they go, you know. So, but at the end of the day, these services are really looking to do basically a lat long test when check availability comes in. They're going to do a lat long test to see, is it inside of any of these, polygons? If it's not, you get this like, I'm so sorry, we don't have Uber here yet. If it is, then you enter the main UI. So if the check availability says no, your experience with Uber is pretty short. You just quit the app. There's nothing you can do. Otherwise, though, you're shown a map. The map has these cars just driving around. I don't know whether those cars are actually real or not, or are supposed to reflect where actual drivers are. Let's just assume right now it's just a graphical affordance to give people confidence that like there are actual drivers in their neighborhood waiting to come get them.
Right.
But they'll see that.
Sorry, I wanted to mention that when you do see the cars on the map, it should reflect the location of the drivers in real time within a specific kind of radius.
Oh, it should. Okay. If that's the case, then as drivers are moving around and they're periodically checking in over the phone, they're gonna continuously send us their location.
Right.
What we will do is we're going to have a geospatial index of their locations, and it's going to basically allow us to do things like I want to find active drivers that are near me. There's a couple of different geospatial indexing technologies we can use. There are things like Redis, where if you have a data set and you have lat long as one of your key fields, it can do things like find me records that are close to this lat long. So we could use a technology like that to find them. Otherwise, we could build our own where, I don't know if you're familiar with the S2 library from Google, but it basically like takes the world and it partitions it into these squares. And we can basically find a reasonably sized square that's appropriate for the Uber application. And we'll just put drivers into the squares. And we can probably put an approximate, you know, just display on the map that shows how many drivers are where just by like what S2 cells we have them in, which could produce probably a reasonable location. But if you actually want their actual locations to drive them on the map, which actually would be quite cool, to be honest, we could probably do something like where we have a geospatial index, and we could just get like, show me the 50 closest drivers, we could show them on the map, just maybe moving around a little bit. And then as their locations update, we can have them move between locations. So it'll give like kind of an approximate vibe that they're moving around. One thing I will say, every time you are opening the app for both riders and drivers, they are constantly sending their location. So I do think there's probably another API that's like you're just constantly going up to the server and sharing your location, and maybe even getting back any updates that need to be sent to you. So both apps almost certainly have some kind of like, hey, I'm checking in with my location, because that appears to happen like pretty much constantly. You'll notice also, if you are the passenger and your location hasn't changed for a while, you'll notice the Uber app asks you, is everything okay? Which is sort of interesting, because I think they're thinking like something bad has happened, like there was an accident or something's gone wrong. So the location is important for riders and drivers. especially for it to do high quality matches or show you appropriate passengers. Obviously knowing where they want to get picked up is important, because like you don't want to drive 50 miles to pick someone up, or you shouldn't. All right. So let's see, maybe those displays on the map. So we're going to have a Redis instance over here, and we're going to have a column which is the lat long for the location of the drivers. So every time they're updating, we're keeping this data set. Now, if the amount of drivers globally is way too big for this Redis instance, we probably want to break it down by these areas where Uber has service. So you could actually partition this out and sort of have a mapping that goes between like the Redis service, the Uber service area, and you could have different Redis instances to support them, and just basically scale them based on how big they are. So on this, we can have multiple of them. And when you're updating your location, depending on what Uber service area you're in, you're going to one of the multiple Redis clusters to keep your location updated. So this is going to update driver.
In terms of
location.
keeping the location updated for both riders and drivers, instead of Redis, can you think of any other alternatives that you could use?
Keeping the location updated?
Yeah, in terms of maintaining it looks like you're storing all the locations of drivers and riders inside this kind of memory store. Can you think of any alternatives that you could use? Are there any alternatives?
Well, the reason I think Redis is appealing here, it's pretty lightweight. So, it has sort of a very simplified interface. It does have this geospatial indexing feature, which is why I selected it. If not, you may want to go, and like this data is pretty ephemeral, right? Like, I don't know that we necessarily would even necessarily need a historical location of like all the locations that ever got reported. Like maybe that is interesting for offline analysis, but for the online use of the application, like where were you 7 minutes ago? It's probably not that useful to know. So I don't know that we need a complete historical log. So if the data is totally ephemeral, we could have some kind of memcache infrastructure where we could go for things like S2 cell ID to the drivers that are in them, along with their more detailed lat longs. So that way I could pull up the map. I can see, oh, these are the S2 cells that are on the screen. I could go and I can pull them out of memcache and look at them. But I kind of like the Redis aspect, and it also saves us from this instance of like, if one of those memcache instances, reboots, Redis at least has persistent storage. So like if it has a hiccup and comes back up, we'll at least have the data as of somewhat recently. We can start to update it and recover.
Got it.
There's probably like geospatial specific serving infrastructure, but I don't know a ton about that. Now let's see. Let's start with request ride. So when the passenger goes and says, hey, when the rider says I want to request a ride, and they provide the pickup location and drop off location, we basically have to have this ride object is starting to get filled in with a state machine that is initially going to be initialized to something along the lines of like match pending. So there's going to be a fairly complex state machine. We'll talk about its existence, but I'm not going to necessarily draw it out with all the arrows of like where it all goes. I think that's probably, I mean, imagine even just getting a simple version of it and thinking through all the possibilities, like what if the driver gets into a wreck on the way to picking someone up, right? There's like a lot of interesting problems that could occur. Like the happy path for the ride is so simple, but I'm sure they had to spend a lot of time thinking about what goes wrong. But the ride is something that we need to persist. It can't just sit in memory, because if the machine that's holding it in memory tips over, the application has to continue working. So we do have to persist it as we mutate this record. So this is going to live in some sort of data storage infrastructure. We need to be able to very quickly find rides by their session ID, by their driver ID, by their user ID. We're going to want to look it up by all those things. So I imagine that we could keep this in some sort of relational database that's probably sharded out for scale. The nice thing you get from relational database, super flexible. If there's access patterns you didn't think of ahead of time, it's oftentimes doesn't totally box you into a corner, like you might end up with a less flexible system. So I'm going to go with a sharded RDBMS type of infrastructure. And what we can do here is we probably want to shard these based on, I'm going to say based on user ID. The thing you want to think about where you co-locate your data is what kind of access patterns do I have that are going to get a bunch of rides by user, a bunch of rides by the driver, like what are the different things that I need to access it by. And I'm just going to venture that we're going to be interacting with rides mostly via their, well, let me think about that. Yeah, mostly via their user ID to go look them up. There can be situations though where let's see if the driver needs to go get it, but the driver will know their session ID. So I guess it's not really, or I guess let me take that back. We're going to stick a ride ID on this thing. And we're going to have something baked into these IDs that the baked into these IDs that let us identify what shard it's on. So there are systems, for example, like Facebook had this kind of interesting model where IDs were these integers, these 64-bit integers, and based on what range it is, it told you what database it lived on. So we're going to use a sharding mechanism like that. So we're going to put together some relational databases. We're going to sit out here. Whoops. So this is a database, believe it or not. Here we go. Maybe we'll fill this in with. And I'm not sure why that's not coming to the front, but oh wait, there it went. Okay, great. Okay, cool. All right, there's a database. All right, so we have a couple of these floating around. I'm just gonna have a couple of these. All right, so now when the user says request ride, we are going to go in and we are going to create a new session in one of our databases. We are going to need a way to locate this session later. So we're going to need a locator that can tell us like, hey, where is the session for me? So in here, we're going to create a new session object. Initially, we're going to fill in, we don't know at this point, we don't know the session that we're getting bound to. We do know the user ID. We know the pickup and drop off location. We're going to give a quote on pricing, and its state is going to be put into something like pending driver match. So it's like a newly created one. It's sitting there waiting to have a driver match with it. So it's going to be sitting in this state. We are going to at this point, we're going to need to basically start looking for drivers to match with it. So we're going to fill in all these records. We're going to give it a ride ID that lets us know what shard it is sitting on, and how to design surge pricing. That is amazing. Now, the pricing, we are going to do that like the most simplistic model. We're going to base that on time and distance. So we're going to rely on a partner like Google to rely on their street routing technology. So you can call the Google Maps API, start, end, and it will give you a route. And we're going to probably come up with some kind of time estimate using a heuristic or something like that. So we get time, we get distance. We're going to use some of our constant, values in the system. We're going to multiply. We're going to give the person a quote that we're going to deliver you to your destination. Using all these parameters. Now we have the database now contains rides that have no matches. Okay, so they're in the system, but they don't have a match going on. We want to have a system that has in memory all the rides that have no matches. So we're gonna have some kind of system here that's going to keep an index of all the unmatched rides. So this is going to be the match service. Now, what the match service is going to do is periodically, we're going to have the match service go into these databases, and it's going to look for all rides that do not have a match, and it's going to ignore all the other ones because the database will contain a lot of like rides that errored out, or they finished, or they're just not interesting. So we're going to have it run a query that's going to give us all the rides that are unmatched, and it's going to keep it in memory, and it's going to do some indexing on them so that we can very easily locate rides that are appropriate for a driver. So it's going to pull them all out of the database. It's going to rearrange them in memory, so it has this indexing it's going to do. And it's going to allow the driver, when it goes to check for matches, it can then call this service, and it should be very quickly able to identify which ones are appropriate for me. We want to present the driver probably with like, we think this one is the most appropriate one for you. I don't know whether they're shown multiple or they just get like shown like, what do you think about this one? Because I think that you want the driver to be able to decline. So for example, like, let's say the rider is going to the airport and you're like, I am not dealing with the airport tonight. It's just like so crazy. I don't want to do it. So they get some choice along with that information, but you do want to present them with some matches. So when the driver comes in after they've started their session, and they come in and they say, I'm going to check for a match, the match service is going to pull one out. If they accept it, then now we have moved the state over to like accepted, and the session that the driver is currently on is now filled in here. So it's actually now it's part of this person's work stream. And that also means that that this person is effectively busy now. So as part of their night, as part of that work stream, they're now busy in some sense working for Uber, although at this point they're navigating to their destination, so they're not getting paid yet. We also when the rider is seeing their app, they now get an update. So you've been matched. I believe they now get a bunch of information from the driver's profile are now shown to them. So, hey, this person, Mary, is going to be your driver. This is what she looks like. Here's the license plate on the car. The car is a red, minivan, whatever. You get the information so that like when that person shows up, you can hopefully identify them and you avoid that you're getting into the wrong Camry. I think everyone's probably like, seen that happen before where, you get into your Uber and you're like, who are you? And they're like, well, this is my Uber. You're like, no, it's my Uber. You're like looking at your phones. You're like trying to figure out what went wrong. All right. So the person's getting that from the ride. The state machine on the ride is now updated to matching. The driver is now going to the pickup location. Once they're there, they say, hey, I'm here. At this point, the rider's app will say, your driver is here. You have, I don't know how many minutes to get down there. So this is another point in the state machine where you're either going to get into like driving the passenger or errored out. They no-showed. If they no-show, I think they do bill the rider for that. I don't know the details of that, but I think you get a bill for just no-showing on a driver. So these ride instances are going to get updated as this is going on. You're going to get a bunch of data about this, state machine advancing, and basically this allows these boxes here to be totally stateless. So these machines here can crash and reboot. It is really not a big deal. Once they've accepted the ride, both the rider and the driver are going to see along their map. They get to see the route. I think the driver gets more like turn-by-turn style instructions, whereas the passenger sees a zoomed out view, and this is how far you are along your way to the destination. So you both get to see that. It is okay for the driver to vary along the route. The route is mostly, I think, a suggestion, and the driver, you can imagine road conditions, right? You come up to where it tells you to go, and there's a police officer who's like, there's been an accident. You just have to go another way. And that is normal, that's fine. As the driver's updating location, that route will update. And even if it's not the one that was originally assigned, I think as long as it doesn't vary too much, you still pay the original pricing. I believe that's true. Now, once the driver gets to their destination, the driver's going to indicate we are here. And that causes another workflow to occur where, they're at this. The state machine is now going to be marked as completed. And there's probably going to be some billing infrastructure that's starting to look for completed rides. When it sees completed rides entering the system, it's going to start aggregating them together, and it's going to do a couple things. One, it's obviously going to bill the rider, but it needs to keep track, probably has a bunch of internal information for what they're charged versus what the driver gets. Obviously, they don't, Uber takes a cut out of this to make money. And so there's some sort of billing job that's going to run. Uber will make sure. Oh, and then I think the other thing to prevent credit card fraud, I believe at the start of the ride, Uber will do I think they call it like a drop charge, where it's just going to test your account. So it's going to do it's going to pre-authorize like $1 just to see if the card is good, because I'm sure it's a real issue with if someone takes a bad credit card and starts a ride. You don't want Uber to be on the hook. You don't want the driver to be on the hook. So it does a little pre-auth, I imagine, when it starts. And then the final charge will go through for the full amount. And then I don't know when drivers get paid. I heard that they get paid pretty frequently, like maybe every maybe weekly or daily or something. So there has to be some job that's basically looking through and saying, like, how many sessions did you drive today? It should be possible for a rider to do, maybe before my 9-to-5 job, I'm going to drive for Uber. After my 9-to-5, so I have multiple sessions in a day. So we're going to find all the sessions that you did today, or maybe that overlap with the day. I started at 10 p.m. ended. So we'll look at all those sessions. We're going to find all the rides that go with, and we're going to aggregate all the prices together and pay you 0.7 worth of that. So that'll get paid out to you via some sort of banking integration. This is wildly too simple for what Uber is, but do you want to put me with questions, or do you want to take questions from the audience? Just more like maybe along the process, or we could also talk about the aspects of the design, perhaps.
Sure. Yeah. So some questions that I have for you would be, in terms of the architecture that you have, can you think of ways that you would minimize latency? What areas do you think could be improved within this architecture?
Yeah, if I was going to make sure that there are a couple of things here that are introducing latency. So one is if you have these complex queries against the database, especially for the read flows, you probably want to take very high frequency read operations and cache them in a way where you can invalidate the cache when there's a write, but otherwise just allow all the front ends to primarily read data out of a memcache layer that sits off to the side. That could really help with reading data out of the databases. The other is this match service here is keeping an index. And the way I described it was like the match service is going to the relational databases and running a query periodically, which means that, kind of by definition, this match service's index of possible matches is always on average 5 seconds stale. Is that a problem? Maybe. You could certainly speed it up by having front ends that are, whenever the state machine is going from a match that's sort of like, we've gathered enough information to make it eligible, it could communicate directly to the match service, say, hey, here's a new one that's available, and send it directly there. Now it's available instantly to match and could accelerate match times. You still do need this process, though, of pull them out of the databases, because what happens if the match service tips over and its in-memory index is gone? So it does need a way to recover from that. And the way it will recover from that is it'll go back to the relational databases and pull down all the matches that are currently available to match. This is a pretty common pattern, though. Whenever you kind of need to keep two data sets in sync in a distributed system, you generally want a bulk flow that gets it all at once. And then if you're fancy, you can do kind of an incremental update to keep it fresh in time. So that's a pretty common approach.
Okay. And then sort of on the same lines, what bottlenecks, what do you think are the biggest bottlenecks in the system with the ride request experience?
The biggest bottlenecks. Well, I guess that depends on what kind of issues we're having. So for example, if the system is running out of scale, how do we scale it out further? One thing that's kind of interesting about the Uber app is it's very geo-centric, and from the sense of I could probably have an instance that handles maybe West Coast US, and I could put that instance on the West Coast of the United States. I could also have another instance that handles all the East Coast traffic, and that just makes me close to my customers. But my applications actually don't really need to know about each other. When does a rider and driver on the East Coast ever need to know about a rider and driver on the West Coast? They don't. Only your data analysts and things will need to know about that. So I could have instances of Uber geolocated all around the world in every country I operate, to the extent that I have a cloud provider there that I'm happy to work with. So I could have instances of it there. And then I think the design as described here, I think it would scale out pretty reasonably. I would have multiple copies of the match service that are all keeping an index in memory. So I would have a symmetrical design there where any of these Uber front ends could talk to any of the match services, and they're all literally just copies of each other. So I think those would be some of the techniques I would apply. This application is kind of unique in that it's totally geo specific. So we can have instances of it that are really close to our customers.
Mm-hmm. And then in terms of, since a lot of the clients are going to be using their mobile phones, do you think you need to be handling situations of poor connectivity? I mean, how would that change anything in your architecture to sort of handle situations like that?
Yeah, there certainly does need to be something that's going on where a lot of what I've described is driven by client access to the system. That's not really sufficient though, because there are situations where, let's say, here would be an example, like let's say a driver and rider were going through a tunnel and they got into a car accident. They don't have connectivity. We're not going to hear from them again, maybe until the police tow the car away or something. And that's a situation where we're not hearing from the client. So there needs to be events that are driven from basically active rides that we have not heard from for a while. So there needs to be something like that where there are these application servers off to the side, just sort of like grooming the rides and making sure things are moving forward in a healthy way that does not depend on calls from the driver or the rider. We may also have weird things where like, oh, we think your session's dead. We didn't hear from anybody for a while. And then one of them pings back, oh, we're healthy, we're on our way. So, you know, we do need to think through those sort of things, probably learn by experience how long is too long to not hear from somebody, you know? It's hard to say, right? Because I know there's some long tunnel. Like, have you ever been in a traffic jam going through the Lincoln Tunnel? Yeah, I could be a while, you know? So.
And then in terms of, do you have to make any special considerations for sparse or dense areas like within this system? Or would that just be handled by the autoscaler on your services?
I'm assuming that even like a New York City sized region or Los Angeles sized region could be handled by a single instance of this architecture. I think that's probably true. I do think there will be lots of interesting things though, where like, you know, the music festival type situation where just capacity is just out of control. And like, it's not so much that we don't have capacity, it's just we have lots of riders sitting on there trying to request ride, and the match service is just, it's matching the people it can, but they're just not enough drivers.
Okay. And so it looks like right now the match service is entirely driven by like the amount of the distance between the requesting rider and the number of drivers in the area. What would you do in order to say add another metric for returning drivers? And I'm talking more specifically about driver ratings.
Oh yeah.
How would you account for that?
Yeah, we haven't actually talked about ratings at all. Ratings for drivers and ratings for riders. Yeah, I think probably you want to try to match your best riders with your best drivers. Additionally, there's a whole bunch of parameters that the rider gets to set that the driver has to match. So for example, the rider is requesting a minivan and I don't have one. So I'm not a good match. So I should not be matched with that person. There's a whole bunch of parameters like that. And then the other is location is one thing, like lat long as the bird flies, but that's probably not really what we want. We want to talk to a routing service and actually talk about like road distance, right? Because like if I live on a cul-de-sac, it might look like I'm close to somebody over there, but the reality is I got to drive all the way out of my neighborhood, all the way around, all the way back. And it is close for a bird to fly it, but it is not close for a car to go there. So we might want to incorporate some things like that, where we're talking about like actual routed distance, not as the bird flies, if that makes sense.
Oh, that does. And I think I'm almost good. I mean, yeah, I would probably say one last thing would probably be like, in terms of notifications being sent to riders and drivers.
Yeah. I mean, mobile phones, you know, you can get, obviously Android and Apple have these notification services, and we probably do have to have that because it's really critical on these apps that you have a UI affordance that works even out of app. So if I've switched over to Spotify and I'm bopping along to music, you need a notification that says your driver is here, get downstairs. So we do have to make sure that notification mechanism is in place. Even though what I posited here is as the app is open, we kind of have this channel to send like, hey, here's my location, anything I need to know. So you kind of do have that channel while the app is up, but you have to have a channel while the app is not, because you have to facilitate matches between riders and drivers even while these apps aren't in the foreground, and that's pretty normal. So very, very important. Yeah, I think there's a question here. How would you handle if the phone loses power or charge? That is a really interesting one. And I would hope that maybe, one thing I might do if I'm permitted in the operating system is when I update location, I might update state of charge. It might be helpful to know just like, oh, their phone died, but the driver indicated they got there and maybe that's okay. Or maybe we give a little bit more of an allowance for like, if we don't hear from your phone for a long time, how long are we going to wait before like how long are we going to wait before we conclude that there's a problem? I think I would imagine that has to get tuned very carefully. Mm-hmm. You don't want to assume something horrible has gone wrong just because you don't hear from a phone. It doesn't necessarily indicate that there's a severe problem. Maybe questions about the interview process flow, because I just to state what we kind of did, like we got a prompt, we kind of talked a little bit about requirements, and that was just me trying to understand like what's in scope or out of scope for the question, like, and does it match kind of what's expected? Because sometimes you'll be like, all right, I need to build a complex user identity system. And like, Hemant was kind of like, no, like that exists, but we don't need to talk about it. So that's fine. So it's sort of like in our heads in the design, but we are not really talking about how it works. But then talk about like, what is the meat of it? What do you really want? It turns out it was like basically like driver, rider match. Great. And some of the things obviously around driver, rider match. Any questions about the interview flow though? Like about how these, anything along those lines?
We have a question from the audience. Aaron asked, what are the key components that you should discuss in an interview like this? I.e. database, user interactions, and what else?
I think it's not so much that you talk about like the database. Like here I selected a sharded relational database. That's got a lot of benefits. It's got some downsides. You kind of just want to talk about the trade-offs. So I think that's really it, is like put a stake in the ground as far as some design decision, but talk about the pros and cons, because there's almost no design decision that doesn't have a pro and a con. Like there's always, like when I talked about, hey, I put a caching layer in there, that's going to make latency go down. Okay, latency went down, but now what? Well, there's all this complexity now in my code about invalidating the cache correctly and yada, yada. I mean, it's not free. And I don't mean that just in terms of numbers, but like it is a tax on the team for forever. If there is ever now an access pattern to mutate a writer object, I have to make sure the cache is getting invalidated. And if not, my application is going to start behaving funny. So there are pros and cons. And so like when I put that cache in there, I didn't really talk about the pros and cons very thoroughly, but I think hearing about them is good. So I don't know it's necessarily the specifics of like what was designed here, and you did see when I was like, oh, we'll use the geospatial indexing mechanism in Redis. Hemant did push back about like, well, yeah, that's fine, but like, what else do you got? So we talked about some alternatives.
All right, we had another one. What kind of abuses would you see and how could you protect against them?
Ooh. This is a really interesting one for abuse. Well, first of all, this is an application that involves money. So right up front, you are in a world of challenge with that. So always whenever, and it's also a post-pay application, you pay after you get the service. So that's just honey for flies, basically, for getting all sorts of abuse. So you're going to get bad credit cards. And the way you try to combat against that is the first is you do a pre-auth against the card. So that's one way that you can at least validate the card is good. It's not been reported stolen at that point. If it has, you terminate the ride. And you might want to indicate on your user's profile that this person tried to use a stolen credit card with your service. And that's not great. So you might want to indicate that this person, whether they knew that, who knows, right? But it's probably a pretty big mark against the person that signed up for Uber and then like is using a stolen credit card. It's not good. But there are other things where you can get a stolen card, but the owner of the card doesn't know it's stolen yet. So you can get away with charging things. Here, you probably want to have a anti-fraud machine learning system that is looking at a bunch of the signals from the sign-up flow. So for example, this person seems to have signed up in Miami, and now I don't know how, but they are requesting rides in Los Angeles with a card that appears to be with a bank in Kansas. Okay, that could be fraud-free, but it also raises my alarms as far as scam. So there's a bunch of things you'll want to do as far as like collecting signals from the sign-up flow, the ride flow, and trying to build a model that can predict this is a fraudulent card. We are not going to collect, or we're going to get a chargeback later on it. So specific policy.
If you had an opportunity to dive into this a little bit more, what would be the kind of interest, what would be the part of the architecture that you would find the most interesting?
I do think a lot of the anti-fraud and payment stuff, I know a lot of engineers don't like that. Oh, payments is like not the most fun area, but I do think it'd be a really interesting one to challenge, to solve with this. I've heard of all sorts of crazy scams from drivers, scams from riders. As far as I can tell, there's all of these attacks people are trying on Uber to either get free money or free rides or you name it. And so it is super interesting. Or drivers that they drop you off and then like they maybe don't indicate it was done and try to rack up more time or distance or something. You know, there's all sorts of scams that. So I think you got to worry both about your drivers and your riders. They're all going to try to be stealing money from the system. So yeah, for sure, it would be something that I would find pretty interesting to try to attack. I'm sure you'd learn some really fascinating things. And the other thing about that anti-fraud work, it never ends. There's always going to be new, creative, interesting attacks. And sometimes these attacks are like, wow, these scammers are so good. Like some of the things they come up with. At least that's been my experience working in this area. Like that, some of them you're like honestly impressed. Like, wow, these scammers are amazing. So it is fun to work against them.
Awesome.
What kind of success metrics would you use for the system?
Yeah, success metrics. I really think about two things with this. I would say keeping drivers busy. So if I have a session that goes 12 hours, how can I maximize how busy they are? I want drivers to be, you know, I don't want them sitting there idle. And the other is I want to minimize wait time for my riders. So those are the two big things. I'm not sure the design of this like the core piece of this distributed system can help solve those, but a lot of them are just economics kinds of things, you know, like making sure that we are onboarding enough drivers. Are we onboarding enough drivers in the right areas? Are onboarding drivers with the right types of cars? Everyone wants a minivan. We're getting all these Honda Civics. Like, well, that's not going to do. What can we do? So a lot of these maybe are like program, policy, economics type of questions, which I think are super interesting. I mean, I love that stuff. But I think when I think about this, though, I think about like, how can I enable those teams, like those economists and those policy people? How can I enable them to get the data out of the system to know what they need to know? So to that end, I would think about like, are there riders we couldn't match just because we didn't have the car type that they wanted? I would really want to get my policy people and onboarding people that data because that's going to help them figure these things out. So maybe we could do things like, if you sign up with a minivan, $500 bonus, you know, things like that. That's actually probably a terrible thing to do, but you know what I'm saying? You could come up with things where you could incent the right behaviors through some economic, you know, incentives. So I would think a lot about that, about, you know, getting those KPIs down, but also that probably means getting data to the policy people that are in the economists to make sure that they're on top of, you know, making good policy decisions that help the system overall. And then obviously with a system like this, obviously we're thinking about revenue, we're thinking about profit. So making sure that we're operating a healthy business, that's of course would be big on my head. The other, while the system is small, obviously growth. Are we getting more riders day after day? Are we getting more drivers on board day after day? Are we retaining the drivers? Just thinking about all these like key growth metrics for the system, like it's operating in a healthy way and it's growing. Those would be the key things I would probably have on my main. Like if I was building the system with a dashboard, those would be on my mind.
Awesome. Well, thank you both so much. Thank you, Hemant. Thank you, Justin, for stepping outside of your comfort zone and going through this live for everyone.
This is a great prompt. There's so much to do with it. There really is. It's a really rich one. So good work.
Yes. Awesome job picking the prompt and going through it. This is such a pretty document. So I hope everyone learned something. This was recorded and will be shared out next week. Thank you all for coming, and our next Tables Turn interview will be on July 29th. Please be on the lookout on our social media and as well as for our fellows within the platform. I'll be letting you know details about that in the next week or so. And so thank you, Justin. Thank you, Hemant, again. And thank you all for joining us. We will see you next time.
Awesome. Yeah. Thanks, Vanity. Thanks.